Welcome to the session. In this session, I am going to cover what is a structure in C++ programming language. In the previous sessions, I have covered what is an array. Array is a collection of similar data type. Structure is a collection of different data type. When you want to define the array that if you are going to define if you are going to define this way, how you are going to define the array? You are going to write int a of 0. Int a of 0. Now this particular variable array can store only integer type. This particular a can store only integer type. If you are writing 5, now it can store the 5 different variables of only integer type. It can store only 5 different types of integer type only. Now if you are using structures, now it can combine different data types. So basically structure binds one or more variables in one structure, and then when it is called, then it creates the copy of that structure and able to pass different values. So this is going to be the syntax for the structure. By the keyword, how you are going to define the structure by using keyword struct, and you are going to give the space and you are going to write the structure name. Structure name can be anything relevant to the structure which you are going to create. Then inside the block you are going to write the members of that particular structure. Now these members, it is not mandatory, it is going to be of only one type. It can be any type. It can be integer, character, string, float, double. It can be any type. But when you are going to declare the array is going to be the collection of similar data type. Now here structure is going to combine different data type. So we'll just see with the example. For example, if I want to take the student details, let us follow the syntax of the structure. Struct space structure name. So here I have given struct space, as I am taking the student details, I am going to give student as the structure name. So inside the flower brackets, I am going to define what are the different members in this structure. So inside the block, I am going to define what are the different members inside the student structure. Now student is going to have the ID and name and marks and percentage. So how you are going to take the details of the student by using structure? So let's get started with the program. Let's copy this one. So before the main, I am going to declare the structure. So struct is the keyword to define the structure, and student is the name given to the structure, and these are the members which are going to bind in the structure. There's nothing but ID, name, marks and percentage. So these are the members of the student structure. Now here, how you are going to call inside your main function. How you are going to call this structure inside the main function. Student space S1. So when you are going to define this structure, memory is not allocated. Memory is not allocated when you are defining the structure. Whenever you are going to call this structure in the main function, now this particular student S1, now memory has been created for this structure, and whenever you want to call the members of student, you are going to make S1 dot and the relevant member name. So basically see here, a structure is a collection of variable types grouped together. You can refer to a structure as a single variable. Here you have taken the single variable as student, and to its parts as member that variable by using the dot operator. Now if you want to call ID in the main function, you are going to make S1 dot ID. When you want to call name of student structure, S1 dot name. That's how you are going to call the members of the student structure. So let's get started. Basically, why we are going to use the arrays? Arrays are going to be a collection of similar data type, and memory allocation is going to be continuous. So continuous memory locations is going to be allocated for the array. Now what is this address spacing? Let's see in detail. Now As my particular operating system is 64-bit, as I am using the Visual Studio compiler, it is considering 32-bit. Irrespective of the operating systems, the compiler treats 32-bit. Now here you can see the memory address is going to start from 00000000 and to it is going for the FFFF and FFFF. That's nothing but each bit is going to be of how many each bit here it is going to be considered as 4 bits because this particular number system is going to be hexadecimal. Each hexadecimal is going to allocate 4 bits. For example, if you are going to write F equivalent in binary, it is going to be 1111. So to define one particular bit in the hexa, it takes 4 bits. So 4 into 8, it is going to be 32 bit. So when you are going to use the arrays, if you are going to use array here, like if you are, for example, in this particular program, if you are writing int a of 2, okay, int a of 2, if I am writing internally in the memory, how it is created, a of 0 and a of 1. A of 0 and A of 1 is created. Now, what is the address? What is the address of A of 0? If you want to see in the address locations, previous sessions I have discussed how you are going to see the address of the particular variable. So, A of 0, you are going to call by the index. For example, let me take, it is going to be considered as 4. Okay, as it is the integer type, the next memory location is going to be of 8. Okay, that's how it is going to be given the contiguous memory locations. So when you are going to define it as 3 here, then the particular memory, in the memory how it is created, it is going to be the plus 4. It is going to be plus 4. Plus 4. 9. Okay, 9. A, B, C it is going to be. That's how, okay. The number systems, if you know the number systems, hexadecimal range is going to be 0 to F. It's going to be 0 to F. So when it is taking 4 here, the next here I have defined already told what is the size it is going to occupy in the memory integer type. It is going to occupy 4 bytes. So whenever I am going to define any data type as integer A of 3, the index is going to start from 0, 0, 1, 2. If, for example, the particular memory allocation given to the A of 0 is 0, 4, the next array value A of 1 is going to be 0, 8. The next memory location given to the A of 2 is 0, 0C. Okay, that's how this particular memory allocation is given for the arrays. In the same way, the structure also memory location is going to be continuous. Continuous memory locations is going to be allocated for the structures also. So I will just show it with the example. So for example, you want to see what's the memory location given to the ID, name, marks and percentage. So how you are going to see address location for ID. Address location for ID is given. What it is given? How you are going to call this variable? You are going to call this variable by using s1 dot. So whenever you are pressing s1 dot, this structure has 4 variables. This structure has 4 member variables: ID, marks, name, and percentage. So whenever you are going to use this particular variables, you are going to use the dot operator. Okay, how you are going to see the memory locations? You are going to use the ampersand. It is going to give the memory location where this ID is stored. Okay, that's how you are going to see the memory locations allocated for any variable. As I have 4 variables, let me see the 4 address locations: name, marks, and percentage. Okay, then here I am going to write name here, marks here, and then percentage here. Okay, now let's run this program and see how the address is going to be allocated by the Visual Studio compiler. So address locations is going to be continuous memory locations. So you can see here the first member is ID of integer type, name is of string type, marks is of int type, percentage is of float type. So in the previous slide I have shown the int is going to take 4 bytes, string is going to take 28 bytes and float is going to take 4 bytes. So here I'll just write it here. Okay, now ID is going to take 4 bytes. Now here name is going to take, it is of string type, so it is taking in the memory 28 bytes. So here again the int is going to take 4 bytes. The int is going to take 4 bytes and the float is going to take 4 bytes. So that's how the memory is going to be allocated for this particular structure. You can see here the starting memory location is going to be 00E2F91C. So just see the last two digits 1C. So 1C, the next location it's going to take 4 bytes for this ID. So it is going to be 1D, 1E, 1F. Next is going to be 20. And for name it is going to take 28 bytes. So from 20 to 2F it is 16 and 30 to 3C it is going to be 12 bytes. So it is going to take total 16 plus 12, that's going to be 28 bytes. Then 3C. So 3C, the marks is of int type, so it is going to take 4 bytes in the memory. So 3C, 3D, 3E, 3F. Next is going to be 40. That's how the continuous memory locations is going to be created for the structure. So it is similar to the array. Array also is going to take the similar data type it is taking. In the structure it is taking different data type, but the memory location is going to be continuous memory locations. Array also is going to perform the same. Okay, I have shown in detail when I was discussing arrays. You can refer that session. Okay, now let's get started with this. Okay, this is how you are going to see the address locations. Next, you want to take, what is a program now? Write a program to display student details. Entered by the user. Using structures. Basically, structure is the collection of different data types. So you are going to give single variable name as student, and how you are going to call in the main function by using student. You are creating the object S1, and whenever you want to call the variable in this structure, you are going to use the dot operator, S1 dot ID. As previous I was seeing what is the memory location occupying with this ID variable, so I was using ampersand. Now next I want to write a program here to display student details entered by the user. Now you are expecting user to enter the details. Okay, now see out, enter the details of student. So he is going to enter the details of the student. So how you are going to take the student ID? So here you are writing, okay, you can write enter ID, enter name, enter marks, enter percentage by introducing cout for each line. Okay, now what I will do, I will directly take console input. In one shot I will take all the 4 variables. So s1 dot id, s1 dot name, s1 dot marks, S1 dot percentage. Okay, now the particular user can see continuously he is going to enter first ID, then name, then marks, then percentage. Okay, you can write it each statement C in greater than the say console input S1 dot ID. In the next line C out statement enter name, then you can write C in S1 dot name, then again in the next line C out enter the marks, then you can take console input like that also you can see, or one shot you can take the all variables in one time only. So he is going to enter the details. Now after displaying this one, after taking the details, now you want to display the student details. That's the program, right? To display student details. How you are going to display the student details? Okay, how you are going to display student name? Student name. So where the student name is stored? Student name is stored in S1 dot. Okay, first let's take the ID. Okay, name. Okay, no problem. Okay, name. Then okay, next I'm going to take student marks. Okay, student marks and then student percentage. Marks here, then percentage. So I am going to see sequentially. Okay, now here I want the ID, student ID. That's how the console output he is able to see this particular lines. Okay, let's run this program and see. So how the execution is taking place? See here. First, it is showing the address locations and then it is moving to the next line, enter the student details. Then it is asking for 4 details. First is going to be ID. So let's give 3, 4, 2, 1. Okay, let me give this as the ID of the student. Then he is expecting the name of the student. Let me write Neha. Then what is the marks secured by the student? Okay, let me write 85. Then what's the percentage? Okay, overall percentage. Right now I'm taking only marks of one subject only. Okay, percentage is going to be calculated. You can perform the average and you can get the percentage also. Okay, then I'm going to write 84.5. Okay, because I have taken percentage as 84 floating point, so I'm going to introduce a floating point here. So next, it's going to show the details. It's going to show the details. Student ID equal to 3421. Student name Neha. Student marks 85. Student percentage 84.5. So this is how you have to see in this line. After showing the address location, it need to clear the screen and it need to take the details and then clear the screen again and you need to show the display the student details. Then that's how you are going to achieve that. See here, after this you are writing here, before entering to next 21 line, you are writing here system pass, then system CLS. This is nothing but clear the screen and hold the console output. Okay, this is console output, it is holding, it is going to clear the screen. Then after taking the details, I want to pass the screen and then I am going to clear the screen and then enter the details. Whatever, display the results, whatever the user has entered, that's going to be displayed. Now see here, it is showing the address locations of ID, name, marks, percentage. Okay, you can note one more point here. See, it is not allocating whatever previously I had shown, that it is not allocating, that's not allocating. Okay, previously it was showing like, see, previously it was showing like 00E2F91C of variable ID, and for ID is going to take 4 bytes, so it is starting from 20, name here, then 3C, marks for the variable, then after 4, see 28 locations are needed for the string of name, then 4 bytes is required for the marks and then percentage here. Okay, percentage here. Then whatever you write the content here, whatever I am writing, the content is going to be stored in this memory locations. Okay, that. Then clear the screen and then you're going to display what he has entered. So let's run this one, okay. Then first of all it is going to execute this one. Then it is going to pass the screen. Then make sure it is going to clear the screen and then it is going to enter to this one, enter the details. Now it is taking 4 details. It's taking 4 details. First it is going to be the ID. So I have made the ID as integer. So I am making the integers only to enter. Okay, name is Ajay. And then I am entering the marks, okay, for Ajay 89. Then what is the percentage? What is the percentage? Overall, I'm giving like 86.7. Okay. Now it is going to clear the screen. Okay, clear the screen because you have introduced here system pass and system CLS. It is going to clear the screen. Then it is going to display the contents whatever you have written here. Okay, it is going to display what are the details entered by the user. That's how you are going to program by using the structures. So let's review the complete thing what we had discussed. So what is a structure? Structure is a collection of different data types. Structure is a collection of different data types. So there are different data types. You are going to bind these different data types by using one variable, that's nothing but the structure name. How you are going to declare the structure? By using the struct keyword. Then after the block you are going to put the semicolon because you are going to terminate this structure. Okay, then how you are going to call the variables inside the structure of student? How you are going to call? You are going to create the object for this as S1 I have created. S1 dot object dot the variable whichever you want to call. You can call ID, name, marks, percentage like this. So you can see, you can call the variable this way, dot operator you are going to use, and the respective variable which you want to call, you can call the respective variable. Then what is this and sign? It is going to show what is the address allocated per ID variable, you can see. And similar to arrays, it is going to allocate continuous memory locations. Whenever you are going to create structure, it is going to take the corresponding whatever the bytes it is going to occupy, the continuous memory locations is going to be allocated. Continuous memory locations is going to be allocated. For example, ID is taking 1C, then next you have declared name, so it is going to take 4 bytes. After that it is showing 20. Then you have written marks, then it is taking 28 bytes, then it is going for 3C, then it is taking 4 bytes, then it is going to be 40. Okay, don't forget this is in hexadecimal, okay. It is going to be 0 to F, 0 to F. So whenever it is going to take 3C, next is going to be 3D, next is 3E, next is 3F, then it will go to 40. Okay, that's how the memory is going to be allocated for the structure. Okay, this is how you are going to take the student details. Student details have the variables ID, name, marks and percentage. So that's how you are going to declare the variables. Then you are going to take the details of the variables, 4 variables in console input. Then you are going to display by using the console output, and each variable is going to be called by dot variable name, the object name dot the structure name whichever you have created the object S1. I have created here S1, so it is going to ask S1 dot the variable name. Okay, that's how you are going to program using structures. Okay, now take as an assignment, try to display the library details, library details entered by user using structure. So here the variables which is going to be required for the respective program is, in the library take the book title. Book title is going to be of which data format? It is going to be string data format. And then try to take the order of the book. Then it is going to be of which format? It is going to be string format. Then try to take the total copies available in the library. Okay, then take it as integer. Total number of copies is going to be in integers. Then next variable, try to take it as price of the book. Price of the book it's going to be in float. So for example, is going to enter 300.50. That's the price of the book. 0.50 also should be included. So you are going to make the data type as a float. Okay, just make it as an assignment and you can do that easily. Okay, so that's all for this session. See you in the next session. Thank you.